Good morning, folks. Today I will be going through a sample final exam problem. This is a representative of what you should be able to do. And just a couple of comments, and that is uh, notice that when you watch the video recording, it says that you have 40 minutes to do the multiple choice question. That is not correct. Actually, on the final exam this year, you will have 35 minutes to do the 25 multiple choice true false slash short answer questions. And I will not be able to do all three problems for you, but I'll do two of them. All right? Take care. We still have a lab tomorrow for those people who may want to collect an extra point if they have already missed something before. Yeah, and I'll be there at 8:30 in the morning and 1:30 in the afternoon. But there will be an activity posted at the regular time. The regular time meaning that and the usual 9:30 for the morning section and the uh, regular 2:30 for the afternoon class. If you have any questions, please feel free to come. But I'm not going to do anything voluntarily. But I will be there. These are, you have a total of 3 hours. The first 40 minutes, there's going to be 25 questions, multiple choice, true, false, some short answers. And you have 40 minutes to work on it. If you finish before 40 minutes, we're not going to give you the software related problem. You have, at the end of 40 minutes, we're going to collect your paper and give you the software related problems. And those are three problems equally weighted. And here's sample. This particular problem was given maybe 3-4 years ago, not in your class, probably in some other, MNG class. There is a variation of this course which is offered to them, but the solution of it is posted, by the way. So even today, I'm not gonna finish everything. Okay, do every single item. If you can always go back and check it out on previous year, 2 years ago, 3 years ago. I don't know. We'll come to this comment later on because I'll do that problem for you. There is a design table problem. These are fairly straightforward if you have done your work. These are no-brainers. This is one particular problem, a part and a design table. There are three variations, the other variation, assembly and design table, a part parameterization, and assembly and parameterization. Any one of them is a potential problem for you guys. Okay, and then finally, I'm going to do this problem. Is think about it as a garage door. Uh, Something like that was done in the lab. In fact, it's one of the exercises in the book, and you can see the solution of it. They could see the solution of it. We had done it in the lab, but this is a kind of variation of that, which if you haven't done that problem or you didn't pay attention to it, it's impossible to do this, okay? Because the same problem except that in disguise. We'll come back to that later. Let's go to our first problem here. So you are asked to create this mechanism. This wheel is supposed to roll on that track, roll, not slide, roll. And the only things that are important are the critical dimensions that I've given you. You don't, for mechanism purposes, you don't need any other dimension. All you need to know is what is this angle of inclination, this angle of the track, and the radius of the wheel, the radius of the wheel, and the location where I want you to extract some graphs. For example, it says, what is the velocity of the point A? A is that center of that circle, which is obviously 4.5 inches from the center of the wheel. That number 4.5 will affect your graphs, okay? Nothing else is needed for this problem. All right. Uh, good, good. I'll come back to these comments later on. Okay. Let's go and make the mechanism first. Product, immediately save. File, save management, save as. On my desktop, on my desktop, I have a folder called Y drive with my UWin ID on it. Okay, now here, same thing with you guys. Every one of you will have a folder under your UWin ID in the Y drive. So pretend that this is that for me. Okay, so I go there, I create a folder called problem one. Problem one. Okay, so anything for problem one is going to go into this folder. That's what I suggest. It's up to you how you want to do it. At the end of the day, I'll look at that your folder, whatever it is, in three problems, one problem, all mixed up, all bungled up. If it doesn't work, that's your problem. It's not mine. So let's make that. I'm not going to worry about dimensions. Okay. So those dimensions are important. Those three dimensions that I gave you are important: the angle of inclination, the radius of the wheel, and location of that point. But I'm going to totally ignore those, and so I'm going to make the track first. Okay, so insert a new part in there. I'm going to call it the track. Right-click properties, track, and track. Okay, let's make it. So on that vertical plane, and there are different ways of making this thing. By the way, let me go to my part design. I'm going to sketch a rectangle. Yeah. I will put one dimension there so that I'm not totally lost when it comes to making this thing. So let's see now, what is this thing? This is 10 inches. Maybe I make this thing 15. Okay. I'll move it a little bit like that. Very good. Exit, pad it. And I'll pad it by 0.5. Those are all left to you. Okay. Now, notice that the drawing that I have here, this track, so this I made 0.5. I'll draw something else here by 0.5 and then pad. So on that face, we will sketch. Okay. So maybe something like that. We'll clean it up. We'll clean it up. Okay. So let's make this thing coincident with that line. And this thing coincident with this line. Very good. Obviously, this angle has to be 20 degrees, at least in the description of the problem, because that affects your graphs and things like that. We exit, and I pad it by 0.5. Good. I need a little pin here because that these arms I want to put it in the pin like that. Okay, so on this face, I will sketch a little circle. Yeah, exit. Why don't I pad it by 1 inch? Good. So that takes care of my track. Excuse me. Go all the way to the top, click on the floppy. So this track is going to be saved in that same folder. Let's do the arms first. The little arm and the big arm. Okay, it really doesn't matter which one is which. I think I call this one small arm, this one the big arm. I don't know why, but insert a new part in there, and I'll call it big arm properties. Big arm, big arm, big arm. Okay, let's make it. Double click on this. Okay, so on that face, I will sketch. And I want to project that circle there because I want the arm to have a hole that size. If you don't like it, go draw a circle. There we are. It's a normal view. And for arm, although it looks kind of fancy here, it looks like that. I'm not going to do that. I'm just going to draw a rectangle. As far as the mechanism is concerned, it doesn't matter. But if you cannot finish the problem and you make things the way you like them because it's easy and you can't finish the problem, then I have no reason to give you reasonable number of part marks. Okay, because all right, so let's go back here. So let me draw a rectangle. And as I said, you might say, well, this doesn't look like that. Yeah, I know. No. You can always clean this up if needed. Okay, good. Actually, let me move this thing a little bit like this. All right, that sure doesn't look like this. All right, so exit, pad it. I'll make it 0.5. Okay, good, good. Let's do the big arm. All the way to the top. Click on the floppy. Everything is going to go in that folder. This big arm, the track is already there, you know that. So insert a new part. Say no, and this is going to be big arm or small arm. Right click properties. Small arm and small arm. Okay. Double click. Let's make it. On that plane, I will sketch. Well, I'm kind of lazy. That's why I'm going to project that circle, that line here. Okay, and I'm going to use it for that purpose of making a rectangle. Just be aware of the fact that you cannot change the size of this or the position of it. Okay, because it's a projection. But if you want to isolate it so that it's no longer yellow, then you can do whatever you want with it. Let me do that. So right click, isolate. That means you can do whatever you want. Okay, so let me go ahead and complete the rest of that thing for me. And don't get bogged down with this. Do it any way you want. I don't care how you do it. There. I'll go actually here. Yeah. Okay. Oops. I just have to clean it up. So we're going to get rid of this. Quick trim. Get rid of this. And get rid of that. Did I not do it? Okay, good, good. So now a little circle there. and the wheel is going to go into this. Exit and pad it, 0.5. Okay, you might say, wait a minute, this doesn't look like that. Yeah, I understand. Hopefully you can finish this problem exactly like the way you're supposed to when you get the full mark on everything, irrespective of the fact that the shape of this doesn't look like the other one. Now, if I ask you in this problem, I asked you in this problem as one of the multiple choice questions. I gave you that, and I asked you a question. The joint between the big arm and the little arm is revolute, prismatic, point curve joint, spherical joint. Pick the best. Revolute, prismatic, spherical, or point curve joint. Which one would you say? Pick the best one. Yeah, prismatic. Yes, correct. Typical multiple choice question. Good. Okay. Good. Let's do the wheel. So we go here. Make sure everything is saved. Everything means this last item. That's the only thing that I didn't save. And then we're going to do the wheel. Insert a new part. And this is going to be the wheel. Right click, properties, wheel, and wheel. Okay, let's do it. Double click on the wheel. On a convenient plane. That looks convenient to me. Convenient. Okay. Sketch on it. A circle. That radius is important because it affects your graphs, velocity graphs, and things like that. But I'm ignoring totally those things. And I will also create a little circle here. The position of that center of that is also important for graph purposes. Now, I didn't want that. I didn't want that green thingy in there. I didn't mean it. So you can always go and check, delete some of the stuff. For example, you go here on the constraint. This last tangency, I really didn't mean it. I delete it. Okay, because then I can move this, put it anywhere I want. I'll make this thing small. Oh, okay, good. Exit. And I pad it. 0.5. 0.5. And on there, I'm going to draw that shaft, which I could have done with multi-pad if I wanted to, but just this. The size of that is not important. However, I want them to be concentric with this. If it's not. Yeah. Exit. And pad it. You know, if you want by one. Okay, good. Yeah, okay. Now, save everything. It's always a good idea to take a few seconds to go to that folder, make sure the stuff that you want is actually there. It was this. Problem one, all the stuff that I did. Okay? All right, let's go back here. So I want to assemble these things. First of all, let me fix that entire track or base. So that is the anchor right there. And let me move these things apart so that you can see them better. Translate in direction X. like that, and direction X like this, and direction X like that. Okay, very good. All right, so this and that, we're going to make it revolute joint, so coincidence between this axis and that axis. And if there's nothing to update, because all I did was to translate it already, it's already coincident. And coincidence between this face and that face. And you already know that even if you did not rotate and you selected the face in the front, by flipping the arrows, you get the effect that you want. But I rather pick the faces that I really want them to be touching. Okay, good. So coincidence between this face, and once again, I rotate, but it's unnecessary, that face. And because it's a prismatic, you already told me that I want coincidence between this edge and that edge. Yeah. Update. Okay, good, good. Okay, so now let's put the wheel in there. The wheel is actually back there. So I want to make this coincident with that hole. Coincidence between, you know what? Actually, let me move these things a little bit apart. So maybe translate this thing in the direction Y a little bit. And Z. Okay, very good. Let's do it now. So coincidence between, well, first of all, let me see now. I want the, for example, the front of this to be coincident with the front of the track, or this piece. Or the back of this to be coincident with the back of that. That's why I padded them by the same amount. Okay? So let's do it like this. This guy and that guy, okay, update. All right, good. So they are coincidence. You can see that. See this? I did this. Oops. And that face coincident. And I want to bring this thing down and put it on that track. There are different ways of doing it. You do it any way you want, but there are different ways of doing it. And I'm going to do one that you may not like. I don't know. But keep in mind, let me ask you a question. Once we put this thing on the track, or if I ask you a question here, what is the joint between the wheel and this slanted track? What would you say? Select the best one. Which one would it be? I'm not going to tell you. You tell me. Between the wheel and that track, what joint would you be thinking of? Say that again. Well, definitely, I'm saying the problem is saying that this must roll on that. So it is going to be roll curve. Now you might cheat and you say, oh, can I do a center of this and the center of, for example, I don't know, center of that? Well, no, let me say it a different way. The center of this going along a line here. I can draw a line. Oh, yeah, but that's not roll curve. That's going to be point curve. And as you do that, this guy is not going to roll. So you do want it to be roll curve. However, to create roll curves, point curves, slide curve, these must be touching first. So you're going to bring that thing down and put it on that track so that the edge of the circle and that slanted line are touching. Okay? So here's how I'm going to do that. Contact between this surface, the outside surface of the wheel, and that surface. And I say, okay, and I update, and it looks like that. Perfectly okay, except that instead of the internal, you should or external, you should flip them. Double click. You see, it has two options: internal or external. Well, think about it. One doesn't work, the other one will, hopefully. Okay, so that's what I want. So you're gonna do this any way you want. Now I want to put this hole inside of that, or this shaft inside of that. So coincidence between this axis and that axis, and update. And you might say, hey, wait a minute, this is separating. Sure, you don't like it, make it longer. But as far as the mechanism is concerned, it makes no difference. So I want to make it look better. I'm going to go to that sketch. This was which one was that? This was that sketch. I just want it to be statically more pleasing. Exit. Assembly. Update. Okay, good. Now, can we check it? Sure. You can go and click on the move manipulate. Right there, move and manipulate. Check the box so that assembly constraints are respected, and then maybe drag the wheel in this direction. So this is the arbitrary direction along that. Yeah. Now, notice that this circle did not roll. I mean, basically, this does not act what it's supposed to, because roll curve, you have to do that manually. Okay? So the fact that this circle is not turning should not bother you, because we are going to do roll curve. Roll curve has to be done manually, because the only way that this may be rotating about that is because it's a roll curve, and this guy doesn't know roll curve, just assembly constraint. And notice that I did bring it and put it in the position that I wanted. Okay, I didn't put it there. It's okay. It's just that I want to start here and go. All right, good. So let's go ahead and save everything. Oh, not there. Floppy. Okay. So now we're going to go to digital markup, DMU kinematics. Get the magic wand out. New mechanism. Auto create. One thing for sure, excuse me, we're going to have a prismatic, a revolute, and a cylindrical. That much I'm sure. Or at least I think, because sometimes what you're sure doesn't always happen, because you put some other constraints in it that ruins what you're thinking is going to happen. As in here. So prismatic is okay, revolute is okay, and cylindrical is okay. I also have this planar, and this planar happened because I wanted to put the front of the wheel on the front of that track to bring it there. That's unnecessary, because it's going to stay there. If everything else is okay, that planar joint is not going to do you any good or any harm. Visualize it. Because of the thicknesses that I chose for the wall and the wheel, this planar joint is totally unnecessary. I can leave it, it's not going to hurt me, but it's not needed either. So if I delete this, don't delete the children in case I ever have to move these things apart. Okay, so let's see. I want a roll curve, right? Roll curve between this and that. So let's check. Roll curve, so on. Slide curve, roll curve. Between this and that. degree of freedom is 1. Because in this problem, you were given the speed of the rotation of the wheel in RPM, which, by the way, somebody pointed out to me, you made a mistake here. Up here you said 10, 30, and down here you said, I think that one was wrong. This is 30, right? Maybe up here. Oh, yeah, that's a mistake. That should be 30. Okay, what I meant was 30. Okay, okay, good. All right, because I did that, I'm going to make that joint, which is a cylindrical one, a angle driven. Now, if you want to see it 0 and 360, we know it's going to work. But if you want to see it simulation with commands so that you're in charge and you drag this thing and it starts there and it goes like that. Notice that it is rolling because the circle is, that little circle on the side is actually rotating. Very good. Okay, so let's see what the rest of the problem is. It says that, okay, after you do this, give it that speed, and we're going to do that. And first of all, make sure that the simulation time is 6 seconds, not 10, 6, okay? Because I want to know whether you can actually do that or not. And then make sure the units are appropriate in the graphs that you give me. And also the trace of that point. The trace of that point at the center of that circle. Now, I don't think we ever created a point there. I may be wrong, but we do that now. We need it to do the trace. So I go there. I go to this wheel. I'm in the wheel now. And I create a point, which is the center of the circle. So the method that we're going to use is the circle, sphere, center, whatever. There we are. Point has been created. So back to our mechanism. Good. So before I put the physics, I can actually plot the trace of this, because the trace of that has nothing to do with how fast this is turning. Okay, it's the same. Yeah. So how do I get the trace? Does anyone remember? Yeah. I'm sorry, say that again. Yes, there is this. You're right. We have to go there, but before doing that, we have to compile it. And not only that, if I try to compile it, it says, where is your simulation? So first you create a simulation. There is none here right now. Just because I dragged it does not create a simulation. First you create a simulation and you know how to do it. You see this guy? Simulation. Don't forget, simulation. First you create it. You see that? It got created. Without this, you can't do the compile or later trace. So you drag this thing. Come on. Drag this thing. Insert. Let's check it out. So choose anything but 1, and we play. So this is just a cartoon. It's needed for that simulation. It's a cartoon. Okay, so stop, rewind. Okay, notice that the simulation has been created. Now you go compile it. Without that simulation, there is no way you can actually do the replay. Compile it. So notice that it says you can generate a replay or you can do an animation file. No. I don't want an animation file. Replay. And just make sure anything but 1 and play it. Let it go all the way to the end. And then your magnifying glass. You click on it. It says, what is the element to be traced out? It's that point that I created. If you're having a hard time, just select it from the tree. If not, from here. And it says, what is the reference product? Is that base? Okay. And then we say, okay. There we are. As this wheel rolls, this goes through a curve like that. In fact, if you put a chalk mark on your car wheel and let the car move for a while, that chalk point is going to trace a curve like that, which is called the luminous gate. Okay, that is not a circle. It is just some weird, complicated curve, which is called luminous gate. But anyway, there we are. Now, save this, because although you created it, when you give it to me, I can't see that because you created the trace, but you never saved it. Some people may have been lucky to capture the image and accidentally upload it because I didn't ask for it. But at least I have some reason to believe that you did it. If you just close this, save it, close it, etc., it's not going to save it. So let's do that. File, save management. You see, this trace right there. Oh, no, not that one. Where's the trace? Wait a minute, did I do that? Let's cancel that for a second. Did it save it for me? I don't think so, but let's check it out. Yeah, it's not there. Let's go back. Let's do it again because I file. We are there. File, save management. Can you help me? What happens is it looks, we have done this thing and it's created as a yeah, it was not a separate part. When you create a trace, it gives you an option of choosing it as a separate part or as a geometrical set. So ordinarily in the past I did a separate part, so that's why I had to save it. Here it's okay because because it's saved it as a geometrical set. Okay, it's all right. If you went that far, I'm perfectly happy. You don't have to save it, okay? Because it's already going to be saved when I click on the floppy. You see, when I click on this, it says new part. I thought it was new part. Let's try it again. Let's do another one. Element to trace out is this. Where is that point? Okay, the point was created in the small arm or the wheel. Oh, lower. Okay, thank you. Okay, there we are. New part. Well, let's try. Yeah, okay, now we can do file save management. There's the trace, okay? I don't know what I did last time. Not sure. Save as. In that folder, trace one, save. Okay. Anyway, let's move on. Cancel this. All right, so let me close that. Let's go back and do the rest of the problem. So it says that, okay, now do simulation with laws. So we go here to f of x. Not, wait a minute, where are we? Okay, we go to f of x, mechanism. We have done this thing so many times that you should be able to do that. Right here, angle, add a formula. 30 RPM is 180 degrees per second. So it's going to be 180 degrees per second underscore S times time. Okay, I don't know what it's talking about. Oh, wait a minute. I picked the wrong stuff. I wanted this to be equal to that. So this is all garbage. Delete the formula here. I put it in the wrong row. Good. It's that thing. Add a formula equal to 180 DEG underscore S times time. Okay, good. Now the formula has been created, and what do we want? We go create a sensor, right? Create a sensor there. Create a sensor. The point is that point. The point is that point. The reference product is the track, and we say okay. And now we're going to do simulation with laws. Activate sensor. What do we want? This problem says magnitude of the linear velocity, not x component, not y component, not z, the one that doesn't have any x, y, z. It doesn't actually say magnitude, but that's the one that we want. And the same, okay, so as a function of time, so we go here. So that'll be linear speed, no x, no y, no z. These are x, y, z. And also the acceleration, because I need two things for you to generate. One of them is the velocity as a function of time, and the other one is velocity as a function of acceleration. So there's two graphs that you have to save, but you have to request both outputs, okay? So we go here, you move this thing out of the way. The problem says over a 6-second simulation. I want to make sure people know how to do that. You click on that, not 10, 6. I mean, these are not major point deductions, but there are point deductions. I mean, read the stuff. Do this the problem that you're supposed to do. It says must do a 6-second simulation. Okay, we'll talk about maybe 1 point, something like that. I don't know. And then you play it, and you graph it, and I get 2 curves. I asked for only one. I asked only velocity as a function of time. Okay, but you also gave me the acceleration because you knew that you had to do something later on. This is perfectly acceptable to me. Although I asked for one, okay, ask for one. But if you give me more than 2, the stuff that I didn't ask, here I'm asking for acceleration later on, not as a function of time, but velocity versus acceleration. I understand. But if I get 3, 4, I don't know whether you know exactly what you're trying to do. Okay, what is the next step? You got this. What is the next step? Print screen. Print screen. Start the Word file. Paste. Fine. Save. File. Save as. In that same folder, which was desktop. Desktop. Desktop? Desktop is the, no, wait a minute, something's wrong. Okay, this desktop, yeah. Right. Not in the document. I've done things like this. And this is in that folder, problem 1. Velocity versus time, or speed versus time. Okay. Yes, you're giving me 2. I understand that. If you want, you can save it as a JPEG file or a PNG file. I don't care. I want to be able to see it. I just said Word because that's the easy way out. Okay. Now I'm going to close this. Now remember, to create other graphs such as velocity versus acceleration, because we asked for both of them, you have to go to options, customize, and create and then pick the right one, velocity, acceleration from the two rows, okay? And then generate it again and save it, etc. You have done things like this numerous times before, so I'm not going to go through it. Close, save. So I did not completely finish the problem because these things you have to do. Now, I want to go back to that comment down below this. It says, it's unfortunate, but if your model does not animate, the only thing that I can check is whether you have made some stuff, which is 4 points basically. Well, I didn't put any points here, but I can tell you that. 4 points for making a box. 4 points for assembly. In other words, I move things apart, update, they go back to where they belong. And if you did the correct formula for speed, okay, I think that has also 4 points. 12 out of 25. Because the rest of them you can't generate. If it doesn't animate, you can't generate velocity, you can't generate the trace, etc. Excuse me. Is there any question? Now, I'm going to save this. And the reason I say that is that it's always a good idea before you drag this thing and you put it in your folder. If you haven't already done that, check it out. These things must be in it. The product must be in it. All the parts must be in it. And the graphs that you generated must be in it. Okay? Any one of them is missing, then obviously there's something. Hopefully the parts are not missing. The graph you may be missing. Okay, that's only so many points. Any questions? Yes. When you were doing the roller curve joint, yes, you selected the edge of the roller and the edge of the track. Yes. Could you select both of the faces, like the face of the roller and the face of the track? It will not take it. It will ask for two curves. It will ask for two curves. Okay. You can do the back circle and the back edge, but it will ask for two curves. Okay, so let me see now. We have look. If you have to go, I understand that, but the second problem is not going to be more than 10 minutes. I want to do that, and I'm going to do it, attach it to this as it is, and post it. If you have other commitments, go ahead. I'll do the talking to myself and then post it. So here's the situation. I'm not going to worry about any dimensions. It's this problem. And this problem, when it was given, for example, on that year, whatever, in that semester, I had done something very similar to that. It was 3 blocks following a elliptical track or a circular track or a track. That is the same problem. I had done it in the lab. It is the same problem, except that the blocks, there's 4 of them here. And for you, I'm going to do only 2. If you can do 2, you can do 4, you can do 20. Doesn't matter. I'll do 2, and the track is not going to be a circle, whatever. It's just like that. This is totally dummy, because if these things follow that, you have the illusion. You will have the illusion that it's also following this. Okay? So let's quickly do that without any dimensions. So I'm going to make 1 track and 2 panels, and then we put it together. And I will not do any saving, please. For you, save as problem 2, folder 2, put the stuff in folder 2, and you know how it works. Are we good with that business of saving? Okay. So let's start with the product. Okay. And we are going to, let me switch my assembly design. Okay, let me do the track, insert a new part. all I will do is call this thing track. The other two I'm going to call part 1 and part 2. Okay, panel 1 and panel 2 if you want. Track and track. Track and track. Okay. There is a little bit of a twist when I do this, but it was not expected to the students to discover it because it was done for them in the context of that three blocks. So it's nothing that was a surprise. They had seen it. So let's go here and draw. Okay, yes, this is ugly. So this control that, make it concentric. Okay, that's a lot better. Okay, how about making this also tangent to that? It's probably already tangent, but maybe not. I don't know. Well, I think it was not. Good. Exit. Exit. Pad it. Sure. That's good. So this is my track. I'm going to insert my first panel. Insert. New part. In there. What did I do? Insert. New part. In there. Part 1. Panel 1. Let's make it. It's just a box. So on a convenient plane, on that plane, I will sketch a rectangle. A rectangle like that. And let me just give a dimension here. And no, control Z. Okay, control Z. Okay. Point, I don't know, point 4. Okay, and just so that we can see it better, I'm going to make this coincident with that. Just minimizing my work later on. Okay, exit and pad it. This is going to be the first panel. In fact, I can use this thing again, but I will not. I'll make it 4. Now, there is a comment that I have to make. And again, this is nothing that people were supposed to discover it on their own. We had done that problem for, I've done it for them for 3 blocks. You see, this, many people did it and it was going well until it reached this point, and then it stopped, or it went further back. I wanted to follow that track. To do that, I'm going to extract this curve and that curve and that curve and join them. So I have a continuous curve to be used later on as point curve join. Okay, so let me go back to my track. And as I said, this is nothing to be discovered by them because we had done that problem. So for extraction, you have to go to generative shape design. And extract was somewhere here. Remember that thing with the box? If I select this curve and control that curve, actually, if you want to do it at the same time, you either pre-select it or use this bag. Cancel. Let me try. This, control that, control this, and then extract. Otherwise, you have to use the bag and select them one by one. And I'm going to join these. This guy, and that guy, and that guy. All right. Now, obviously, if it goes around an ellipse, because the ellipse is probably one piece, you don't have to do some of this stuff. But here you have to, no choice. But people have seen this. So let's go back to our product, insert the other panel, insert a new part. What am I doing? Cancel. Insert a new part in there. No, let's make it. Why don't we make exactly the same thing on that face? On that face, we'll sketch on that face. Okay, I draw something like that, and we'll clean it up. I believe that we made this thing 0.4, if I'm not mistaken. This. Right? Oh, there. 0.4. 0.4. Okay. And I don't know, I'll make this thing coincident with that, just to make my job easier later on. That's all. Coincident. Okay. Exit. Pad it by 4 inches. Now to pad, obviously you have to be in part design, not in generative shape design. Pad it by 4 inches. 4. Okay. All right. So pretty much we're done. Go all the way to the top. Okay, I didn't save anything, so everything is just hanging there. So let's anchor this track. Anchor that. So I want to create a point curve joint between this curve, the joint, and that point. Another point curve joint between that joint and this point, etc. So that's the strategy. So let's go ahead and before I go any further, can you tell me what kind of a joint is between these two panels? If you had to give me a good answer, a reasonable answer, between these two panels, what kind of a joint do I have? Yeah. Well, just before it can't go like that. There's no problem. As a matter of fact, I don't even need this part. All I need is just join to make something. Okay, that is just that's just cosmetic purposes. All I need is a path like that. Okay, but my question was something else. Was what is the joint between these two? Oh, by the way, I see what you're saying. You're saying they interfere with each other. Okay, I could have make it a trapezoid or something so that it goes through each other, but it really doesn't go through each other. Yeah, I see what you're saying. That's fine. But what kind of a joint between these two panels? Any suggestions? Yes? There is no contact between two edges. Don't they hinge? That's just a revolute joint or a cylindrical joint. Either it does this, right? This is a revolute joint. This is cylindrical joint. Now, if it goes like that, obviously it's going to be cylindrical. But this. So my point is that between these two is going to be cylindrical or revolute, depending on how you do it. Now I can put them together now if you want, or I can do that later. As a matter of fact, let me create all these joints manually for you. You don't have to do that. You can put the constraints there and then create it. Okay, but I'll leave it like this. Okay, so let's go ahead to digital markup. Get the magic wand out. There is really not much that it's going to do except there is an anchor there. That's all. That's all there is to it. There's an anchor there. That's pretty much it. Anchor. There is no constraints. Okay, fine, fine. So can I anchor it? Okay, it'll create an anchor new mechanism. Fine. Okay, so you can see that now. Did I anchor this? Hang in there, just a second. No mechanism. Okay. Okay, it did create it, right? Right there. Say it again. Oh, okay. Okay, very good. Okay, good. Good. Thank you. All right, so let's go. Let me bring this thing in the front. Let me bring this thing in the front so that I can look at it. So, point curve between this curve, the join, and that endpoint. So let's do that. Point curve between the curve. The curve is that join, which was in here, right there. The point is this point, except that I can't select it because these guys are all blocking me. There, point curve join. Say okay. Same thing on this one. So another point curve join. The curve is the join. Okay, let me select it from the tree. The point is this point. Okay. Now I can do a point curve for this one, but it's not necessary. If I make a revolute here, they're going to stay together. So let me just do one point curve join for this endpoint. Point curve join. The curve is the join. The point is that endpoint. You might say, why didn't you do it for this? It won't be necessary because I'm going to create a revolute there. They're going to stay. If this guy stays on the curve, that guy will stay on the curve because it's revolute. So revolute, line, this line, and that line, and planes, this plane, and that plane, and say okay. We put it together. Okay. Let's check our degrees of freedom. Okay. There is one other thing I'm going to do that may not be obvious to you because it says degree of freedom is 2. I'm going to make sure that this plane stays on that plane. Because otherwise, this thing can fall, but it can also wobble around that curve. So let me hide this. Let me bring this in the front. I don't need this. Hide this. Okay, a planar between this and for the other plane, let me hide that. One of these two, it doesn't matter which one. And lo and behold, degree of freedom goes to 1, and I'm going to make one of these point curve joints length driven. So let's try that. Length driven. Say okay. Good. And let me bring the track so that doesn't bother you. You can see it. And just pray. This better go around the track. Yeah. Look, we didn't expect people to invent this. This problem was done for people with 3 blocks going around a track. Any questions? If you had more panels, you would do exactly the same thing. Another revolute. Another point curve. Another revolute. Another point curve. Those revolutes, by the way, could have been cylindrical because of that planar that I put in there. Those hinges could have been cylindrical either. Okay, this is it.